something really fast. You tell me what it is. So what is this right here?
Ester.
Right. How about this one here?
Carboxylic acid.
And this one here?
Acid.
That's right. And who was the most reactive?
Acid chloride.
That's right. This guy's going to be the most reactive. Alright, so for the first two steps, the first 2 points that we listed from your notes, we're going to be making carboxylic acids. Carboxylic acid with those 2 steps. So our aim is to make this guy here, right? And we're going to take 2 different pathways to make this guy. Right. So the first one was Grinard, carbon dioxide. All right. So we're going to have a Grinard, and we're going to react it with carbon dioxide. And then we're going to generate carboxylic acid. So we're going to start off with an alkyl halide. Start off with some kind of alkyl halide. All right, some RX. Right, and we're going to react it with Mg ether. Right, this is the reaction that produces the Grinard. Right, so this guy here just slots in here, and we produce the Grinard. Cool. Is that hard? That wasn't hard, right? We just produced the Grinard, right? Now the Grinard is going to behave as a nucleophile. All right, so the Grinard behaves as a nucleophile. So the nucleophile of this guy here will look like this. Right, so the Grinard behaves just like a nucleophile. And so what it's going to do is we're going to now react the Grinard with CO2. Right? So this Grinard now, we're going to react it with CO2, and we're going to form carboxylate. Right? So how does that happen? Well, we start off with our RMGX, right? And this is carbon dioxide. That's how it looks like. And remember, we just said that this guy here is just going to behave like R minus. So this section of it is the nucleophile. Right? So you can just ignore this part here. This section is the nucleophile, and it's going to behave like that, R minus. And so now this R minus here is going to act as a nucleophile, and it's going to attack this carbon here, and this electron will swing here, and we will produce where this carbon here is this carbon here. Does that make sense? And then we just protonate this guy. We assume there's going to be some acid, and we protonate this guy here, and we generate the carboxylic acid.
So what happens to the MgX? It just goes away?
Yeah, just somewhere there. Somewhere there. It's unnecessary. Well, it's necessary, right? But it's unnecessary. Right?
Okay.
So this is our product. So this is a way we can generate carboxylic acid. right? If we start off with an alkyl halide, this is the way we can generate a carboxylic acid, right? So if you start off with some alkyl halide, let me show you something really fast. So let's say, for example, now, let's say I started off with this, right? Actually, if I start off with this, an alkane, I can react this with Br2H or heat, right? And I can generate this guy here, right? And then once I generate this guy here, well, this is an alkyl halide, right? But let's say I wanted it to be primary. I can do an elimination reaction. I can do an E2, and I can get this. Reform a double bond, right? So do you guys remember what this reaction was? This is just the halogenation, the radical, an alkane, radical halogenation alkane. And if it's bromine, it's more substituted position. If it's chlorine, it's less substituted position. So you put this guy in the more substituted position. I'm showing you, like I said, this is that you might see something like this. So he likes synthesis, right? And taking stuff from organic one, right? So we add the bromine here, right? And we can do an elimination. Whenever you see this base here, this turbietoxide, you're mainly looking at an E2. Or you're actually looking at E2 for the most part as an elimination. So this is going to be an E2. Then from here, what we can do is we can react this with HBr and peroxide. This is going to give us an anti-Markovnikov addition. And the Br will be here. Then we can turn this into a Grinard. Okay. So this will just that's right. Just go here. And we would have that, right? And then once we form this, what do we react it with to get the carboxylic acid?
CO2.
That's right. So once we react it with CO2, notice that notice that here I have 1, 2, 3 carbons, right? This is 4. So I should have 1, 2, 3, 4 carbons. So it's going to elongate the carbon chain by 1. And now notice that I form a carboxylate and not the carboxylic acid. So I have to protonate this guy.
Is it fair to just say workup?
Yeah, acid workup will do. Yeah.
Okay.
Does it make sense?
Yeah.
So this is just one way of forming the carboxylic acid. And all the carboxylic acid derivatives can hydrolyze to a carboxylic acid, right? Right. So I'm just showing you maybe a synthesis that you might see.
That's helpful because he does definitely like that.
Right. All right. Let's move this aside here. Alright, so that was one pathway, right?